All right, so what we're looking at here is an array of different molecules in the lipid category. So one of the key identifiers as far as being able to identify lipids versus, say, proteins or carbohydrates is that you can notice that there are a lot of carbon and hydrogen in here. So it's primarily made up of the white and the black. And then sprinkled in, we have some oxygen, some nitrogen maybe, and we have a phosphorus. Okay, so that's the first thing, is first saying these are lipids. Now, what do we know about lipids? We know that they are hydrophobic, okay? They are water-hating. They are going to stay with themselves. They don't want to dissolve into the water, and that's because they are non-polar, okay? So they don't have the charges. So the first thing that I want to point out is, let's kind of move these to the side. And let's start with this guy right here. Okay. So this is what we call a triglyceride. And a triglyceride is simply 3 fatty acids, 1, 2, 3, and they can be of varying lengths of carbons, okay? So some are shorter, some might be longer. Each one might be a little bit different. They can be fully saturated with hydrogen or not, or they can have some double bonds in there, okay? So when we talk about unsaturated fats, that means that there's a double bond. If there is saturated fats, that means that every carbon is going to be saturated with the hydrogen, all right? Now, here, you're not going to have to worry about whether it's saturated or unsaturated. And these fatty acids are going to be bonded to the glycerol molecule. So these 3 carbons right up here at the top are the part of the glycerol molecule, and that's why it's called the tri-3-glyceride molecule. Again, this is a non-polar fat in the body where we can store a lot of energy. So now I think it's a good time to bring in this other small molecule, okay, so that we can compare this. And I'm going to set the triglyceride down. I might refer back to it here in a second. But this 3-carbon structure is the glycerol molecule, okay? And so this serves as the backbone for the triglyceride. And so I might even turn this around here so you can see these 3 carbons very easily. And when we look at the triglyceride, I don't know if you can tell this on the tape, but right here, 1, 2, 3, these are the carbons from the triglyceride. Each of the fatty acid chains underwent a dehydration synthesis and attached to the glycerol molecule. So therefore, 3 fatty acids plus 1 glycerol, when it forms the triglyceride, is going to produce 3 waters in that dehydration. Okay, so glycerol molecule. The next lipid that we are going to look at is something that's pretty simple. Once you've seen that triglyceride, when you look at this, it looks a little bit like that fatty acid tail, and that's exactly what this is. A string of carbon and hydrogen with a carboxyl group at the end tells me that this is a fatty acid. Okay, so these are the things that would come together to form a triglyceride. All right, and that leads into this big molecule right here. Okay, so this is what we call a phospholipid. So what do you see first? 2 tails. Okay, so these are fatty acid tails. This is hydrophobic side of this. Right here, we have these 3 carbons. That's a glycerol molecule. that that attaches to. But wait a second, we don't have that third fatty acid chain. Instead, what we have is this molecule here, these two molecules that are bound to the glycerol molecule. And purple is going to be phosphate, okay? And so phospholipid, there's the phosphate group that's attached in lieu of the third fatty acid. And this is a nitrogen, and so this is sort of an R group. It can be different structures over here. And this side of the phospholipid is hydrophilic, meaning it's going to react in water. And this is hydrophobic. And again, we call this molecule an amphipathic molecule, meaning it has a negative water-loving side, or a water-loving side, and a fat-loving side. Okay? The very last lipid that you're going to be responsible for is this guy. This is cholesterol. Now, how do I know, how can I identify that? Well, cholesterol has 4 rings to it. Again, rings are the geometric circular shape created, in this case, by the carbons. And so let me just kind of point out that we got 1, 2, 3, 4. A 4-ring structure that has a little bit of extra stuff on it. And this is cholesterol. Cholesterol is the basis for making all the, for example, steroid hormones like estrogen or testosterone. So we have to start with this molecule. Okay, that is going to conclude the lipid section of the biomolecules.